Hello everyone, my name is Qiheng Fang. I'm a rising senior at NYU Shanghai. Today I am presenting my third project, a design of the exam and course time scheduling system. I have special thanks to Professor Olivier Marie for his help and guidance. It is very crucial in successfully completing my project. Motivation. At NYU Shanghai, it takes the Office of the Registrar a long time to schedule exams and courses by hand, and sometimes they are not able to find an exam schedule that works for every student, or not able to make a course schedule that allows students to take all the courses they want because of time conflicts. As students ourselves, we want to design final exam and course schedules that both meet our needs as well as the school's requirements. While avoiding time conflicts for students and professors, we also consider some soft constraints such as reducing early morning classes and spread out the exams within the final week. Some of the seniors have made the skeleton of the app, and my job is to normalize some of the codes, implement new functions, and make the algorithm easy and accessible. Overview. Time conflicts occur when scheduling exams and courses. Numerous studies on finding an optimal schedule have developed algorithms that create the fewest time conflicts, while fulfilling as many other requirements as possible, such as no early morning exercises, late evening exams, and no consecutive exams for a student. The problem of assigning exam time is usually depicted as a graph coloring problem, where vertices represent courses and edges between two vertices represent the same students who are enrolled in both of the courses. The weight of each edge is the number of such students. The goal of these algorithms is to have a graph with two connected nodes of different colors, where color indicates different exam time. In this project, for exam scheduling, we will schedule the exams within the final week and optimize the schedule by fulfilling other soft constraints. Course scheduling problem incorporates more complicated constraints like professors' availability and course meeting patterns. Each course listed in the alphabet is represented by a vertex. Because the course schedule needs to be generated before students' enrollment, we try to leave as much freedom as possible for students. We separated the courses into different levels based on their difficulty and used a greedy algorithm to color the vertices on the same level differently. The rationale is that we assume lower class men and upper class men will be interested in courses of different levels. If we can make courses in the same level having different meeting time, students will be able to have the most freedom to pick courses. However, if we have to schedule several courses on the same level into one period, we give priority to courses for the same major to have different meeting time. This helps students to fulfill major requirements. Also, besides generating a schedule, we implement a regenerating algorithm that can easily regenerate a schedule based on the existing one when small changes happen to the course and exam information, such as deleting an exam or changing the time of an exam. Moreover, on the website there are buttons that allow you to export and import the result. Docker is deployed so that environment will not be a problem for our users. A bash file is written so that we do not need to open the command line to start the algorithm. Instead, double-click will do the job. I will elaborate more in the following sections. Deploy Docker. Docker is an open platform for developers to build, ship, and run distributed applications, whether on laptops, data centers, or the cloud. Docker enables true independence between applications and infrastructure and developers to unlock their potential and creates a model for better collaboration and innovation. We need to create a Docker file first to tell Docker what we want in a container. After that, we have to push the Docker image to the online library. We have to go to hub.docker.com to register using the command docker login to log in to our account. and then tag the image with account name and version. For instance, in our example, it is scheduling 0.0.1. After that, we can run the image by calling in the CMD window docker run plus the account name and the version, so that it will automatically run if it exists locally. One great thing about Docker is that even if it does not exist locally, it will go to the online hub to drag the image, and this greatly helps us to access it without actually pulling it from the to the local. For instance, every time we update the Docker file, what we only need to do is to push it to the library. Each time the professor tries to access it, it's very easy via the internet. After which, after using Docker to compile everything to the container, Professor Marine hopes that I can find a way to start the container with a double click, since it's very hard for professors at registration to deploy the environment and use command line to open Docker image himself. So he suggested that I use bash file to implement the function. What is a bash file? A bash file is a kind of script file in DOS, OS2, and Microsoft Windows. It consists of a series of commands to be executed by the command line interpreter stored in a plain text file. It simplifies repeatable computer tasks using the Windows command prompt. I personally use Notepad++ to write the code. We have to end the file name with .bat extension. There are some very useful functions inside the bash file. For instance, @echo. This parameter will allow us to view our working script in the command prompt. This parameter is useful for viewing our working code. If any issues arise from the bash file, we will be able to view the issues associated with our script using the echo function. And the other one is the start function. This will head us to a website of our choice using our default web browser. So by sending this bash file to the professor, he can just double click it, and we will be able to run the Docker file. In order to make the scheduling more user-friendly, we would like to export the result we generate to a CSV file to enable schedule communication between professors. That is to say, once a professor is satisfied with the schedule, he can send the CSV file to another professor. After putting the CSV file into a specified directory, the other professor will only have to click a Load Exam Schedule button to display the result in the browser. In the following screenshot, we can see that after we generate the schedule, we will open an empty CSV file at the same directory of the Python file and write the schedule into the CSV. Each line represents a specified time slot. Import the result. As we can see from the code below, by reading the result.csv, mimicking the format we used before, and pass the result to the template exam.html, it should generate the result we want. However, simply passing none to the JS will pop uncaught syntax error, unexpected token illegal. The format cannot be recognized by JavaScript. So here I consulted online, and I use json.dumps bracket string to handle this error, and it works. Therefore, here comes the JSON. JSON, JavaScript Object Notation, is a lightweight data interchange format. It is easy for humans to read and write. It is also easy for machines to process and generate. JSON is built on two structures. One is a collection of name or value pairs. In various languages, this is realized as an object, record, dictionary, or hash table. The second is an ordered list of values. In most languages, this is realized as an array, list, or sequence. These are universal data structures. Virtually all modern programming languages support them in one form or another. The seniors used to compile all the results from a list to a string, so that they send the string to the front end. After the front end gets it, it needs to decode it and then separate it, present it in the screen. However, this is not very useful, and actually it's quite troublesome. A more standardized way is to use JSON to transfer it, pass it to the front end, and the front end and use another JSON function to decode it. It's very easy and fast. Lastly is about the advantage of the greedy algorithm. I compare it with the brute force that I wrote to see how efficient it is. In the brute force way to finding the result, I keep a global variable. This is a list of dictionary called result. The key of each dictionary is the color, while the value of the dictionary is a list of courses. We loop through all the vertices, and each time we extend the list by adding all possible solutions. I ran it for 1 day, but it didn't give me any result. It's really time consuming. So for the next step, what I plan to do is that to use the greedy algorithm to generate multiple results, and use icons to make the professor at the office of the register easy to access different results. And from there, he can see which result is to his satisfactory, so that he can pull out one and use that as the final result. Thank you for listening.